So, welcome, Pushan. Today we're going to talk about TVO, or total value of ownership. So, first, what is it?
Yeah, thank you for having me in, Kevin. At a simple level, TVO is about understanding what a technology or a product or a material does to the customer's business beyond the purchasing price. Now, traditional thinking would always ask, what does this component cost or what does this solution cost? TVO asks, what operational, financial, or lifecycle impact does this create? And you will see that in the advanced systems that we see today, even a very small change in material selection or material decision can influence uptime, qualification speed, maintenance, for example, and ultimately cash flow.
Well, that's interesting, Pushan. And eventually we'll come to materials innovation, which I think is something that both of us are very excited and interested in. But in the context of TVO, I think most people are familiar with the idea of TCO, which is total cost of ownership. So now you're talking about total value of ownership. So maybe you could elucidate a bit more by comparing and contrasting the two.
Sure. Now, TCO or total cost of ownership, let's say 20, 30 years back, it was already a major step forward, right, from traditional procurement or strategic sourcing thinking, because companies moved beyond the purchase price into things like maintenance, operating cost, downtime, etc. Now, total value of ownership takes it one notch higher, right? It asks, can this solution create measurable business value? And often this is measured in either cash inflow generation or cash outflow deferment, for example. I first started working with this concept about 13 or 14 years back with strategic sourcing functions that were heavily focused on, year on year delta. The challenge was helping those organizations connect the sourcing decisions to operational and business outcomes and not just year on year negotiated cost reduction.
Well, that sounds really quite relevant given today's status of the world and supply chain disruption. So, but let me ask you, to whom do you see TVO most applying to today and why?
Yeah, now you see, Kevin, that today's systems, whether we talk about AI infrastructure, data centers, semiconductors, these are far more interconnected systems of smaller modular subsystems, right? And then on top of that, the innovation cycles of these systems are also getting compressed, right? Now, let's say in an AI infrastructure, a connector or a coating or a thermal interface material, for example, they can influence much larger outcomes like uptime, cooling efficiency, liability of the asset over time, or let's say qualification risk that you may stand for. Now, on the other hand, what I mean by the shrinking cycle time, now if you look at, let's say, a standard data center infrastructure program used to take about 60 months, right? For example,
Mhm.
10 years back, right? Today we are talking about 18 to 24 months. So total value of ownership is really gaining importance today with a lot of advanced materials, performance chemicals companies, but also with tier ones, OEMs, system integrators. And when you talk about the functions that are nurturing and practicing total value of ownership, it has definitely moved beyond procurement teams where it originally started. So today we see business teams, marketing teams talking about and practicing total value of ownership. But also I see increasingly R&D organizations, innovation organizations also thinking in terms of the value that is being created economically beyond the technical performance of the solution.
Well, I guess then the demand for TVO is to really kind of envision the downstream and to be able to look multiple stops down the road as well as into the future, which gets us talking about scenarios, right? But you did mention things like various technology stacks, and there's a lot of things that we're talking to our clients today about: semiconductor chips, small modular nuclear reactors, grid configuration. So the challenge, I guess, what I'm hearing from you is to the inventor is where does my invention fit? How do I sell it most effectively? When do I use TCO versus TVO arguments? And if I am a buyer, how big do I have to think, right? Do I think of the product from a value perspective at the chip level, the server, the rack, the data center, the grid? Where does TVO stop and end? Does it ever?
Now, that's exactly the challenge, Kevin, right? I would say the simple answer is you follow where the economic consequence or the result shows up, right?
Mm.
Now, imagine a material may enter very much upstream at a component or a subcomponent level, but the value that it generates may appear much more downstream at the system level. For example, let's say a thermal material which improves warpage control, which is related to dimensional stability inside a chip package or a chip system. Now, this may ultimately show up in the server reliability of the asset or the cooling load, resulting in, data center uptime or downtime, right?
Hmm.
And that's why many material companies struggle today, in my opinion, because we are looking at selling material properties while the customers are evaluating system outcomes.
Well, that's interesting. Well, give me some examples of how you have used TVO to guide clients to thinking about their new product innovations and introductions. I would imagine that be effective in marketing a late stage new product, for example, looking to make a footprint in the marketplace, or perhaps be even more valuable in coming up with new designs and concepts before even setting out into the R&D.
No, that's very interesting, Kevin. And let me start with the second example first, thinking about innovation direction. Now, one such example involved where we were looking into traditional specialty minerals. Imagine talc and kaolin, right? Now, these have been in the market for quite some time. These are mature, but we were evaluating applications in fire retardant coating systems. Now, by understanding the functional stress zones, imagine a fire smoke and toxicity endurance or FST endurance, or a mechanical crack resistance on fire or viscosity control, right? We
Hmm.
could identify where the materials such as talc and kaolin would create disproportionate value, which then eventually guided the future formulation and innovation priorities, right? Now, this is a classic example of innovation use case, right, of
Hmm.
total value of ownership thinking. Now, let me take the other example, which is more downstream. Let's say somebody wants to introduce a new product. Now, we're working with a high performance thermoplastic, which is a new proposition, and we needed to thoroughly test its viability in electric vehicle connector systems. Now, instead of positioning this thermoplastic very broadly, we tried to understand where within the connector systems, which subparts, the material would create the strongest operational value around areas of thermal stability or dimensional stability, lower warpage, right? High voltage connector components, for example, right? So TVO helps both commercialization as well as R&D prioritization use cases.
Right. So basically, TVO can help a R&D guy view the world through the lens of a potential customer or a persona and really visualize the desired end result from the customer's perspective. So, but let's say that I'm already down the road, I have a product and I want to actually have the right conversations with the right potential customers in a highly competitive scenario. Can TVO help me here?
Oh, yes, absolutely. Let's take the example of a battery casing. Now, let's say a premium material which can potentially be applied to the casing may initially look expensive on a per kilo basis, right, compared to the incumbent material in use. But once you model, let's say lower scrap, fewer line interruptions, improved uptime, the economics change very quickly. Now, just to give you context, imagine a large battery manufacturing setup, which will typically be in, let's say, three-digit million capex, right? Even small improvements in yield or downtime
Hmm.
translates into millions of dollars annually. And that's exactly where the total value of ownership becomes powerful as a negotiation tool if I were to talk to my customers in a highly competitive scenario, because now I am translating the technical performance or the technical promise into operational and financial language.
So perhaps a good example could be how an upstream innovator can use TVO to assess and build different scenarios that are driven through techno-economics to visualize the market potential as well. So not just the consumer, the customer, but and to understand who is willing to pay for that particular benefit.
Yeah, we saw that in data center infrastructure environment discussions. The client already had a very strong material proposition and innovation capability, right? Now, the challenge was to understand where the future system bottlenecks were emerging, like thermal stress zones, mechanical and dimensional stability, like warpage zones, which is very critical in such environments, the liquid cooling compatibility, for example,
Mm,
the signal loss, or on the other side, let's say signal integrity that we're talking about, right? And of course FST, fire protection properties, right? Now these signals, when we prioritize, it helps clarify where the future material innovation needs are actually needed and where the economic value can be created where customers are likely to pay.
okay. So for our FSX clients out there, what should they be thinking about and what should they prepare to have a conversation with you and your team about TVO?
Three things I would say. First, start with the system bottleneck, right? Not the material itself. Second, we need to ask where the customer economically feels the improvement of the solution that I'm talking about. And third, we need to have an enterprise thinking where we need to connect R&D thinking, commercial thinking, operational thinking, and link that to the material qualification together. Because increasingly, the value is being created at the system level, not at the standalone material or component level.
Let me squeeze in one last question because I did mention this idea of TVO and innovation. So from what I understand from what you're saying, Pushan, TVO helps me become a better systems level thinker from the perspective of the end use because now I'm anticipating the total environmental performance of where my material, my component fits into the overall system. So if I am thinking about innovation, future innovation, and building an innovation center, perhaps with my supply chain partners or others that I want to attract to my way of thinking, how can I use TVO to really kind of drive the organization of that effort?
Yeah, so I would say that we need to start with looking at our core capabilities, right? On the innovation, which is the core DNA. But then I need to completely flip it, right? To where are the technological disruptions happening? And then come backwards in terms of what are the stress zones and what does it translate to in terms of matching my strengths, right? And this is an org-wide discussion, as I said, enterprise thinking, wherein we start from the end and then we involve a strategy, we involve end markets, we involve innovation to eventually design where do I want to innovate and create a premium value proposition for me, not only for today, but let's say in the long term.
Well, this has been a great discussion, a first discussion, Kushan. So I think in the next episode, what we'll do is we'll dive deeper into these specific industry examples that you mentioned and unpack how TVO reshapes innovation and commercialization conversations across different materials ecosystems.
Looking forward to it, Kevin.
Thank you.
Thanks, Kevin.